Welcome to Data Basics with ASCBP. In this series of videos, you'll be learning the basics about data structures, statistics, and variables, and how to test relationships between variables using Excel and some basic R skills. In this first video, we'll be talking about data structures and variables, or the ways that we categorize and describe our data. So before we get into working with data, first let's talk about what data are. First of all, data are plural. A data frame is a file made up of many different pieces of information, often stored using numbers. And a data set is made up of all these pieces of information about multiple units. And these pieces of information about each of these units are called variables. So let's say we have a data set about people. That's our unit. And for each of these units, for each person, we might collect some information like their age, their gender identity, their favorite color, or maybe their number of prior felonies. So once we have our data, how do we describe and characterize it? Well, data are made up of many different parts. First, we have a unit of analysis, which is who or what we are going to study. And then we have different types of data, which is just the structure of the data frame, the way the information are laid out that we'll need to collect. And then we have different types of variables. So what kind of measurements are we going to have? Then we'll need to assess the quality of our variables. And finally, we'll need to decide what are our independent and dependent variables. So what kinds of relationships between these variables would we like to study? So data come from populations and samples. So a population is every single unit in existence that we're collecting data about. So let's say we want to collect data about people in the state of Pennsylvania. The population would be every single person that resides in the state. A sample might be a couple people from every single county in the state. And that brings us to our third point. Our sample needs to be representative of our population so that we can generalize the results of our study to that population. One of the first things to consider when we're going to be collecting and looking at data is the unit of analysis, which again is just who or what we are studying, or the level of aggregation of the data that's being collected. This could be individuals, groups, or even events. Next, we'll talk about some of the types of data that you can collect. There's cross-sectional, repeated cross-sectional, time series, or panel data. Cross-sectional data are data that have measurements for multiple units of analysis at one single point in time. So for example, if I took a survey of inmates in Pennsylvania prisons in the year 2016, there are multiple units because I'm surveying multiple inmates, but there's only a single point in time. If we're talking about years, I only did this in 2016. Or maybe I collect data on crime rates in Texas cities for the year 2018. Repeated cross-sectional data are a little different because this refers to multiple cross-sections. So this is just cross-sectional data collected on a new sample of units in multiple different periods of time. So instead of sampling and surveying prison inmates in Pennsylvania in 1 year, I randomly sample 1,000 inmates in 2011. In 2012, I take another random sample of 1,000 inmates. In 2013, I do another random sample of 1,000 inmates. This is repeated cross-sectional data. Time series data are just data that are collected from repeated measurements on a single unit over a period of time. So if I were to count up the number of 911 calls to the Fairfax County, Virginia Police Department every month starting in 2010, this is time series data. I repeatedly count the number of 911 calls to this single unit, the Fairfax County Police, over a period of time, 2010 to present, let's say. Panel data are repeated measurements on the same group of multiple units over time. So let's say maybe I survey the same group of 1,000 prison inmates in Pennsylvania for 5 years in a row, and I ask them the same questions every year. Or maybe I gather data on the crime rate and the number of police officers in all New Jersey towns for the years 2000 to 2010. These are panel data. So this is just a quick little table to go over different types of data. If you have a single unit measured at a single point in time, you only have one number or one piece of information. So this isn't data. If you have repeated measurements on a single unit over time, you have a time series. If your data are measured at one point in time on multiple different units, you have a cross-section. And if your data are taken in repeated measurements on multiple units, this is a repeated cross-section or panel data. Now that we've seen the different types of data, it's time to start to dive into the different types of variables. So variables are just different attributes for each unit in our set of data. And there's 4 different types of variables. In the qualitative group, we have nominal and ordinal variables. And in the quantitative group, we have interval and ratio variables. Nominal variables are purely qualitative in nature, so they don't have an intrinsic numeric value. Information in nominal variables can be stored using numbers, but it can't actually be numerically quantified in any way. There's no natural ordering to it. So an example of a nominal variable might be hair color, race, gender identity, favorite color, things like this. Ordinal variables are categorical and can be logically ordered. The categories can be seen as being higher or lower than another. For example, the highest level of education completed, less than high school, some college, a college degree, a graduate degree. Each one of these can be seen as being higher or lower than the next. However, a property of ordinal variables is that moving from one category to another is not necessarily the same as moving from that category to another. So there's no standard distance between each category in an ordinal variable like there would be in, say, a string of numbers. 1, 2, 3, you have a distance of 1 in between each of these. But what is the distance between some college and a college degree? It might vary depending on the person. There's no set interval. Another type of ordinal variable that we might come across pretty often are called scales. And scales are ordinal variables that come from surveys about people's attitudes or feelings towards something. People are usually asked to agree or disagree with statements like, the level of immigration to the US is currently too high. The police in my community are doing a good job. Or maybe the United States should intervene militarily in Syria. And respondents are generally asked to select one of the following options from strongly disagree to strongly agree. And there's kind of different ways to range these, but this is one of the most common. Another kind of ordinal variable that we might see is called a factor. So scale variables are often combined into constructs called factors. And the idea behind this is that if you're trying to measure a specific concept, more measures are better at capturing the whole thing than maybe just one single one. So for example, you could ask people, is your neighborhood safe? But rather than just giving an unspecific yes or no answer, you might construct a scale into a factor from the following couple of items. So you might ask people to agree or disagree with a couple statements like, police in my community make me feel safe. It's safe to walk around the neighborhood at night. I would allow my children to walk home alone from school. I don't worry about crime in my neighborhood. Or maybe my neighborhood is safer than other neighborhoods. These questions all relate to neighborhood safety, and we could add up to the responses to all of these questions and call the factor feelings of neighborhood safety. Next, we have something called a dummy variable. A dummy variable is just any multinomial qualitative variable, a nominal or ordinal variable, and it can be recoded as a binary qualitative variable. For example, if we have a variable called race, and it's coded numerically where 1 means Asian and 2 means black and so on and so forth. We could dummy this variable out into 5 separate binary or dummy variables. So you might create a new column called Asian, where 1 would indicate that they have that trait, they identify as being Asian, and 0 would indicate that they do not have that trait, they do not identify as being Asian. And we could do that for each of these 5 options, thus creating our 5 separate dummy or binary variables. Moving on to quantitative variables. These are variables that contain cardinal information, or we have the ability to know how much greater or less one value is than the next. And these are classified into interval and ratio variables. So these can be things like age, income, temperature, things that have an intrinsic numeric value. So what's the difference between an interval and a ratio variable? Ratio variables have a true 0. So for example, an income of 0 means that you have no income, you have $0. Or having 0 prior offenses means that somebody has never committed a crime, or at least never committed a crime and gotten caught. So consider what it means to lack a true 0. For example, temperature in degrees Fahrenheit, what does 0 degrees Celsius or 0 degrees Fahrenheit mean? It doesn't mean that we have no temperature. Usually that just means it's very, very cold outside. 0 in this case does not mean the absence of temperature, and thus this interval variable, temperature, lacks a true 0. In order to use our variables in data analyses, we need to assess our variable quality. And there are formal ways to assess whether or not a variable is of high quality. And there's 4 primary criteria for how we do this. They're called precision, accuracy, validity, and reliability. Precision refers to the specificity of a variable. So for example, it's more specific to say that a man is 45 years old than to say he's in his mid-40s. And again, it's more specific to say that a man is in his mid-40s than to say that he's just in his 40s. Other things being equal, we want our variables to be more precise, because more precision means that we have greater power to measure causal effects. Accuracy refers to the extent to which the data don't contain errors. Now, we'd love to believe that all of our data are correct all of the time, but this simply isn't true most of the time. In fact, people lie on surveys, and people sometimes just don't know the answer to the question or just don't have an opinion. So what's the trade-off between precision and accuracy? Let's consider the following example. If I asked, how happy are you on a scale of 1 to 5, 1 being very unhappy and 5 being very happy, this variable's pretty reasonably precise. You have 5 different choices, but maybe we could do a little better. So if I asked you, how happy are you on a scale of 1 to 100, 1 being very unhappy and 100 being extremely happy, this is much more precise, but would it be accurate? How well do you think you'd be able to describe your level of happiness on this scale? Would you even be able to discern the difference between a 44 and a 45? This is the trade-off between precision and accuracy that you have to watch when you are creating measures for your variables. Let's move on to validity. Validity measures the quality of our measurements. In particular, the degree to which what we can measure is reasonable and acceptable substitute for what we want to measure. So if we ask the question, do violent movies cause children to behave badly? It's really not that simple. First, we need to think about and construct what we mean by violence. So if I choose one specific definition, like the number of murders portrayed in a movie, is this a valid measure of what we're interested in measuring? This is what it means to construct validity. So maybe violence isn't just the number of murders, maybe it's the number of punches or the number of fights. These are things that are very important to think about when you're constructing your questions that are going to measure things and that are going to make up your variables. Finally, reliability refers to whether a particular measurement technique applied repeatedly to the same thing will repeatedly yield a same or similar result. Reliability is about consistency. It has nothing to do with validity. A measure could be valid, but not reliable and not yield the same or similar results every time. Or the measure could be reliable and yield the same results, but could be completely invalid. Finally, to wrap up the video on variables, we have independent and dependent variables. So when we're doing research, we classify variables according to how we intend to use them. We're interested in some kind of relationship between two variables, and we might think that one depends on the other. So the cause is represented by the independent variable x, and the effect is represented by the dependent variable y. The effect depends on the cause. And when we talk about dependent variables, these are the outcomes that we're interested in learning more about. And we will do so in the next videos upcoming. Thank you for watching.